Greetings and welcome back to AP Computer Science Principles. This is Unit 5, List, Loops, and Traversals. We're on Lesson 9, where we're going to introduce traversals. All right, the traversals explore. So for a warm-up, I want you to remember how list works, right? The variable name and then each of the elements in it. If you actually create it, they're separated by commas. The index starts at 0. And that's element 1, element 2, element 3, element 4. Their length of this is 4, but the index is 0 to 3. Which again, as we bring back into loops, that's why we do our for loop starting at 0 and going up to the number we need. Now, we can also use numbers. It doesn't really matter. It just stores a piece of other elements. We get the booleans in there. It's just, the key is you give the name and you fill it with those items. So we're going to go ahead and kind of talk about how to go through this. And we want to figure out how can we get the value or even know if a value is in a list. So yeah, obviously if it was, we just look at it, how do we find it with a computer program? So I mentioned that for loops and lists/arrays work really, really well together, because that's why we mentioned they start at 0 and they go up to the length of the list, right? They can traverse it. Now, if there's 4 items, then this works. But what happens if throughout the program you're adding stuff and whatnot? Well, we'll get into a nice little way to work on that, which this kind of shows us right here. The list.length gets the length of it. And if you remember, we don't use the -1 here, because let's say there's 6 items in the list. That means list.length is 6. Well, that works out perfect, because remember, you go from 0 to 5. Remember, 0, come on, nice little pointer out, 0 to 5, which is the whole thing, right? It stops at 6. It doesn't go to 6, which is good because 6 is out of range. It's not actually in the list. So by putting the length of it there, it works out perfectly. So I mentioned this is a great way to what they call traverse through it. So of course you could build this thing at home if you wanted to, and it just shows, you know, I is nothing when it starts, 0, 0, 1, 1 again. Now here's the beauty of this, right? Here's the beauty. Var element equals list I is 0, so it gives you the first one. I is 1, it gives you the next one, right? And it just keeps going through that. And this loop will loop through every single element. And then you can do stuff with it, right? So let's kind of talk about this more in depth. This is, we mentioned why we start I, index, again, index, iterator, because this whole thing iterates, whatever you want to call it. If you're doing a loop, it makes sense to call it index. I like to call it iterator because, again, you iterate through this. But because of our design, it works out great for the index as well. So when we run through this, var element will be our first one, and then it comes back here. I becomes 1, which is the second element. And this is really important that you put an I here, right? You put an I there. Kind of like when we had our other ones, when the other apps where you go left and right, and you had index here. We had a variable for index. Well, it's kind of that same concept, except for we're just using this one that already goes up by itself. This is, again, very nice because we can get the length of it. List.length gives us the length. That is the name of an actual list. So obviously list is probably not a great name for your list, but say you had temperatures in here. So we had temps.list, we had a list of temperatures. And then of course we go up by 1, right? Because we want to hit every single item. So all said and done, we now can loop through every single item and then eventually add some code to this in order for it to work. So I'm going to loop through. First one, 0, 0, because that's I. Remember, I is 0, so it's going to give us the first index. So 77, right? So when we do this, it's 77. Now, it's going to go to 1, right? So we change it to 1. The index 1 is 85. So now we've just saw 85. Now it's going to go up to 2. And we'll run through this as an actual program so we can see it as well, but that is kind of what it is. And we kind of actually, in one of our last activities, when the practice, whatever, we saw it looping through as well when we actually just console logged I. So let's go. 2 is 89. And then 3, very last one, because remember the length is 4, so it's not going to go past it. So 3 is 65. And now it's 4. 4 is the length, so it's not going to actually go into this. All right, we exit loop, we're done. Hopefully you're starting to see a pattern of how we can easily go use loops to traverse a list. Now, what about this situation? We want to get the element and check. Remember how we mentioned, how do we know if one of the elements is 85? Well, we have our nice little thing. We just went over the loop with it, able to iterate through each of the indexes. So if element equals 85, console log, element is found at index I. Because again, that's what index we're not. Else, not here. So as we start looping through this, we can see how this works. So when it's all said and done, this is the end of the code. We have 4, all right? I is 4, which means it's done. It means it didn't run. So at 0, not here, right? I wish I had the array down here. But if you remember, 85 was the second item. I think it was like 87 something else. 65 was the last. Yeah, 65 was the last. So 0, not here. Goes back up. It's 1. 1 is 85. So it prints element found at index 1, which is why we have this. And then 2, come back up. 2, that was 87. It's not there. And then goes up to 3. Come to 3 was 65, which is why it ended here. 65 is not that, so then it's not here. And then it's 4, and it's done. So this is why we saw the console log like this. Now, if element 3, or in index 3, right, the last element was 85, then it could still say, not here, element found at index 1, not here, element found at index 3. So it can keep doing that. With the code that we have here, all it's checking to see which of the elements is 85. And it says, this is 85, this is 85, this is 85, not here, not here, this is 85. That's what this code is doing. We could also find the smallest number by adding a little bit of code here. If the element is less than the minimum, change the minimum to the element. So it will change to 5. I do believe it's, yeah, okay. You do need to actually create this var minimum and stick that at the top of all of this code right here. So we set the minimum to the first one, so that way whatever that was, I think it was like 70 something, so is 70 something less than 77? No, so it's not going to change anything. Then it comes up. 85 is number, yeah, 85 is number, well, index 1, 85 is not less than 77, so it doesn't go to this. And then number 2 is 87. 87 is not less than the minimum, so it doesn't do this, comes back. And then we're at 3, 65. 65 is less than 77, so 65 now becomes the minimum, which is where they got 65. Now we're at 4 and it's done. So that's kind of how it looped like that. Again, I wish I had all the codes. You can see that they had the minimum needs to be put up here. You do need to set it, and you always just set it with the first one, so that way if the first one is the lowest, then it'll just stay the lowest, right? Because if everything else in the array is not less than it, it'll never trigger this, and it'll stay the lowest one. All right, so we're kind of making through all of this. We have, if you remember, a nice little substring, basically 0 to 1, which is only 0. So this is checking to see if it starts with an A. And then you can append item to list animals A element. So basically they're creating a new list called list animals A, and whatever the element is, we could add it to it. Basically this is checking for all of the animals that start with A. Alligator, all those fun things. And then it'll say nothing to see here if the animal doesn't. All right, so hopefully, again, you can see how, gave you a couple examples of why you would want to and what you can do with it. Kind of some of the things we've already gone over, already more or less kind of looped through some lists, but this is the way to set it up, right? The for statement. Oops. The for statement, var I equals 0, because that's where index starts. I is less than the length of the array, so list.length, and then I++. And then you just, and this is the part, this is what gets a lot of students. To access it during the loop, you do list bracket notation I, list bracket notation I, and that gets you in the right spot. And finally, we're going to watch one little video, and then finalize wrapping it up.
With lists, we can begin to store lots of data, and we can also think about writing code to process that data. For example, a list of the pixels in an image can be processed to change their colors to give the image a unique filtered look. A digital song file is actually just a list of waveform samples and can similarly be processed to apply digital effects. We know that computers are great at repeating commands in the form of loops, so when we want to process every item in a list in a similar way, we can use a loop to iterate through every item and take some action with it. Let's look at how we use loops to process lists. First, we can make a while loop to run a specific number of times by using a variable called count. This loop will run 6 times. We also know that lists have numbered indexes starting at 0, and since the variable count stores a number, we can use count as our index into the list. And since count changes every time through the loop, starting at 0 and going up by 1 until 5, this gives us a mechanism for accessing every item in a list. An easy first step when processing lists is to write a loop that prints out all the values in the list to make sure you are seeing everything. Let's do that here. We'll add a console.log statement in the loop and make the loop condition more general by removing the hard-coded value 6 and replacing it with the length of a list. Now, if the list size changes, our loop will still print everything out. Let's run it. This kind of looping structure, one that uses a variable to control the number of times the loop iterates, has 3 basic components to it. Creating and initializing a variable to use as a counter, some condition that checks the value of the counter each time through the loop, increasing the value of the counter by a set number for each iteration. This kind of structure is so common that many languages include the for loop to do just that. The for loop combines these components into a single line of code for convenience. The standard setup of a for loop looks like this. There is a lot going on here, but you can see it has the same basic components as the while loop above. It creates a counter variable called I, while I is less than 4. Add 1 to I every time through the loop. You might read a for loop out loud like this. For variable I starting at 0, while I is less than 4, I++. You can think of I as shorthand for index, and I++ is shorthand for increase the current value of I by 1. The value of I will come in handy when we use it to access each item of the list, just like we use the counter variable in the while loop. Note that I is just a convention and you can name it anything you want. Let's look at an example of using a for loop to go through every item in a list and doing something with each item. Here we have a list of red, green, and blue values for a very small image. We could brighten it up by adding 50 to every number in the list. In each iteration of the loop, we are getting the current value stored in the pixel list at index I, adding 50 to that number, and then updating the value at that same slot in the list to the new value. So the first time through the loop, I is 0, pixels at index I, or pixels at 0, is 28. 28 plus 50 is 78. Pixels at index 0 is updated to be 78. The next time through the loop, I is 1, so pixels at index 1 will be accessed and updated in the same way. This will happen for each item in the list. With a for loop and a list of values, you have an easy way to process all of the items in a list. This is a foundational concept in computer science you will see over and over again, and it unlocks the power of dealing with lots of data.
All right. So that's the end of this lesson. Again, traversal is the process of accessing each item in a list one at a time. So basically it combines the list and a loop so that you can access each of the items in a list. All right, that's the end of the lesson. Have a great day. We'll see you next lesson.